So we left off ready to talk about inverses, right? I think I kind of talked about them a little bit, reminded you. We just have to do it now. Okay, so example 4, ask us to find the inverse function for each of the following if one exists. So, reminder things. First of all, f of x is the same as saying what? Y. So this right here is the same as saying y equals x over x plus 1, right? Now, what's the first job in finding our inverse? I would say it depends on exactly what you mean by that, but I would say switch x and y. So every y becomes an x, and every x becomes a y. So instead of y equals, I'm going to write x equals. Instead of x over, it's going to be y over. Instead of x plus 1, y plus 1. If you want yourself a reminder note, I'm going to put up here, I'm going to try and squeeze it in the corner to switch x and y. Okay? Now, after we switch x and y, what do we do?
Do you do the multiplication thing? So y plus 1?
Okay. Yes, because what's our job?
To find x.
It's already x equals.
Yeah.
So find y, right?
Yeah.
So your job after you switch x and y is to solve for y. Okay? In order to do that, we have the fraction issue. We need to get it out of fraction form. So we're going to multiply by, now, y plus 1. Get rid of the denominator of y plus 1, multiply by y plus 1. What we do on the right, we're going to do on the other side. Now, with that in mind, x times y plus 1. What is x times y plus 1? Okay. If you go ahead and distribute it, which I believe we will need to do, so if we go ahead and distribute this, it does become xy plus x. On the right, what happens with the y plus 1s? They cancel, leaving us with y. Bless you. Am I done? I have y equals, but what's the catch? There's still a y in the problem, isn't there? So, work to get y's on the same side so we can decide what to do from there.
Yeah.
Which means we should probably, what?
Subtract y over.
I would say dividing by y isn't going to make life any better. I have a y term on one side, an xy term on the other side, so I would try and get them together. So I'm going to subtract the xy term over to the other side. Okay. My idea here is I want all my y's together. With that in mind, on the left, that leaves me with x. On the right, that leaves me with y minus xy. All my y terms are together, yes. We've still got to solve for y somehow. Thoughts on what to do? No, we're still trying to solve. Can't divide by negative x because there's that other y term there.
Can you divide by x?
No. Not with the other y term there. Is there a GCF on the right?
Yeah.
A y. Let's factor a y out. Now, at some point, can I flip-flop sides at some point? Would that make life better if you can, if I flip-flop sides, I'm still going to go ahead and factor the y out because you guys are competent. So if I factor the y out, it's y times what? 1 minus x, not just negative x. There's a 1 minus x there. equals what was on the other side, x. We see where to go? Now I can divide. What's being done right now? It's currently what? Y times 1 minus x. If it's y times 1 minus x, to undo multiplication, you can divide. What am I dividing by? 1 minus x, because I want to get y by itself. So we're going to divide by 1 minus x. On the left, my 1 minus x's cancel, and I have y equals. On the right, x divided by 1 minus x is x divided by 1 minus x. Okay? So all solving steps you know, just a little bit more challenging. Okay?
Like that was a lot more just yeah.
Technically, it was more than just flipping a sign, but I see what you're saying. If you look at from the beginning to the end, like that's all it ends up being. But
Will it be like that for every problem?
no. Okay. Now, what's another way to write y here? What were we finding? We were finding the inverse. So I'm going to write this as f inverse of x is how I say it. Or it's f to that. It looks like negative 1 power. It's not negative 1 power. It's just inverse. Equal to x over 1 minus x. Now, I do think out of my A, B, and C examples, A was the most difficult. Okay, so that's the good news. You got A out of the way. Okay, let's practice with B and C. First of all, what do we know about f of x?
Y.
It's a fancy way to say y. I'm not going to rewrite it this time. Okay, what's our first step?
Switch x and y.
Okay, if we're trying to find inverse, x's and y's switch. So instead of y equals, x equals. Instead of square root of 4x minus 3, it's square root of 4y minus 3. And now?
Square both sides.
Okay, your job is to get y by itself. Y is under that square root, so we are going to square the square root to get rid of it. If you square one side, you square the other. On this side, x, when you square it, becomes x squared. What happens when we square square root? The square root and the square cancel each other out, leaving me with 4y minus 3. I said this one was easier, didn't I?
Yeah.
If it's 4y minus 3, what are we doing?
You add the 3 over.
Add the 3 over. And I'm going to flip sides. At this point, I have 4y equals x squared plus 3.
Yeah.
And
Divide by 4.
divide by 4. Now, as we think about how to express this answer, there's different ways that we could go here. If you divide the left by 4, we know we divide, everybody gets to divide by 4. You can do one of two things. You could do one big fraction bar, or we don't do this as much often, which is why I'm showing it. You could do individuals. I'm not saying there's a right versus a wrong here. Both are good for different reasons. It really, and in this scenario, we're just writing the equation. We're not doing anything with it at the end. It really just kind of depends on what you're going to use the equation for as to, what it's better. In this case, y equals, do either of those really reduce?
No.
They don't. X squared over 4, me personally, I would probably write it as 1/4 x squared plus 3/4. I would say this form would be easier for me visualizing the graph. I can visualize what the graph is and what's done to it pretty well. Could you have just said x squared plus 3 all over 4? Yes, you could have done that just as well, and that would be equivalent. Again, if I was wanting to plug values in, I would use the other form, x squared plus 3 over 4. So they're both good for different reasons. I'm going to rewrite my final answer as f inverse of x equals 1/4 x squared plus 3/4. I do think for the answer key for tomorrow, if I recall correctly, I think I tried to put both variations of answers on there. Okay? Questions there? Okay, one more practice in this lesson, or this section, excuse me. What do you know about f of x? It's y. What do I do to find the inverse? Switch x and y, so y equals becomes x equals 4x squared minus 7 becomes 4y squared minus 7. How would you like to solve? Okay, working to isolate y, so we're going to add 7. I'm going to go ahead and flip mine here. 4y squared equals x plus 7. Now what?
Do you want to divide by 4 first, or you want to?
My preference is divide by 4 first. Like you, how I can tell you're asking, no, you wouldn't have to. I like to just because that number is not always a perfect square. So, you know. Now, on this one, I'm going to show the other way. Could I just leave it as one big fraction?
Yeah.
Yeah, you can. Okay. So now, grab the wrong color there. What do I have? Y squared equals x plus 7 over 4. Okay, yeah. To go from y squared to y, we know we want a square root. With that in mind, a couple of things to check here. Square root of y squared is y.
Would it just be the square root of x plus 7 over 2?
Possibly. I was going to do that here in a second. What else do we need to talk about?
You put the 2 out in front of
The plus or minus sign?
We'll come back to the 2. Did we just take a square root in an equation setting?
Yeah.
And when you take any type of, I'm going to say square root. Now, when I say square root, think even roots, yes? You have to throw in a plus or minus. Not with your odd roots, but with your square roots, or even roots. Now, with this in mind, I'm going to go ahead and switch to f inverse of x equals. In terms of final form, technically, are we supposed to leave fractions under radicals? Technically, no, because we're not supposed to have radicals or square root signs in the denominators. Now, what several of you noticed, okay, can I take the square root of x plus 7? No, that's stuck there. Can I take the square root of 4? Yes, and so what I would write this as is plus or minus the square root of x plus 7 all over 2. I started to say 4 out of habit, but all over 2. Now, the one thing you've got to be careful of, make sure your radical is just showing in the numerator. Okay. Anything else? Are we good on those? Got the basics. Okay. One more section. There's really 2 topics here that we're going to talk about. Okay? The 2 topics we're going to talk about, inverse reflection principle and inverse composition rule. Now, we're going to state them and then we'll look at our examples that talk about them. So, inverse reflection principle. This is just the fact that a function and its inverse will always reflect, well, okay, what is it? They use the words symmetric across the line y equals x. Now, symmetric across the line y equals x, if it's symmetric across something, it reflects across something, right? So symmetric across the line y equals x. What's the line y equals x? Yeah. So the line y equals x is that perfect diagonal line that goes through 0, 0, 1, 1, 2, 2, 3, 3, yada, yada, yada. Okay? So the idea here is a function and its inverse reflect across this line. Okay, so not your typical vertical line or horizontal line, but a diagonal line. Okay, now keep in mind, what do a function and its inverse also do? They take their x and their y and they switch. So if you think about it, for instance, the point 1, 3, I'm making this up, okay? But if it's 1, 3 up here, what is it going to be when you reflect it? 3, 1. Does that make sense? I'm just trying to, that I didn't put the marks there, but I'm just trying to get you guys to visualize that the point 1, 3 would become 3, 1. Does that look like a reflection across that diagonal line? Okay, that's the idea I need you to visualize. We're going to practice here in a moment with example 5. Okay. The other piece we're going to talk about, inverse composition rule. I believe we talked about this in algebra too. A function is one-to-one with an inverse function if and only if f composed with g of x equals x and g composed with f of x equals x. So if and only if, what I refer to as Fogg and Goff, both equal x. Okay, so that's another way to tell our two functions inverses. When you put them together, when you compose them, do they give you x in both cases? And that's what we're going to talk about here. Okay, so that's example 6. Example 5. Let's look at it. They ask us to sketch. Okay, sketch, do the best you can type sketch here. The graph of the inverse function for the function drawn on the grid provided. So we have a graph here. We're being asked to sketch the inverse. Now, curiosity, what graph does this look like to you guys?
X cubed.
This looks like an x cubed, doesn't it? It might be a stretch or something, but like an x cubed moved up one maybe. Okay? So, now, the inverse. We're trying to go across that diagonal line, right? Right? So we're trying, if we just do a visual, I can't do this without like standing directly in front of the board. Okay. Can you see those dots a little bit? Okay. What we're going to do is we're going to reflect across that line. Okay. Now, with that in mind, what's blue on my paper, that blue graph, how do I want to say this? It's on both sides of that line, isn't it? So when we reflect it, what's on this side is going to have to go on this side, on the other side. What's on the top side is going to have to go on the bottom side. Sorry. I know how to do this. This was just a hard one to explain. Maybe it's just me, but it's a hard one I feel like to explain. Okay? So, I don't know. Is this something you can visualize if we reflect it across that diagonal line? Some of you are going to say, yeah, I can visualize that. Some of you are going to say, yeah, I don't know what it's going to look like. Now, if it's on a piece of paper, could you take your piece of paper and fold it on the diagonal line? Mm-hmm. Easier said than done in a small graph, but you could. Here's what I like to do. For instance, what's that point right there? It's currently 0, 1. So what's it going to be in the inverse?
0, -1.
0, 1 is going to become what? 1, 0. Because what happens? XY's become YX's, right? So that point that's on that graph, when I move it over here, is going to be down here. Okay? Can you do that with lots of points, with as many points as you want? Yeah. For instance, what is that point? -1, 0? What's -1, 0 going to become? 0, -1. I know this is it's going to look kind of hard to figure out at first. Kind of hard to tell, but anything on my graph that crosses that diagonal line, guess what? If it's on that diagonal line, it's the same, yes? So it looks like there's a point, I don't know, maybe around -1, -1, somewhere right there, yes? That point's going to stay the same because it's already on that diagonal line. You can try and pick more points. You can also just realize if it's reflecting across that line, it's going to, you have to mirror it, right? So one thing I try and do, if I try and mirror this, if I'm just looking right here in this center section, okay, like from right here between these two dots, it kind of curves away from the center, yes? So what's this one going to do? It's going to curve away from the center. Sorry, I want a smaller. It's going to kind of curve away from the center, okay? Where we also know we have to connect where? We have to connect to that point on the line, yes? Now, think about it. What's this piece down here? What's it going to do when I reflect it? It's currently going down, right? What's it going to end up doing? Going out? Does that make sense? Like this piece right here is going to end up going over here. It was running kind of along the y-axis. Now what's it going to be running along? The x-axis. Visualize some of those points if you want. Now, what happened at the point 0, 1? It was out there, yes, and then we had what I would call a turning point, yes? The graph turned here. So what's my graph going to do here? Or here's another idea. Here, let me go back and grab. Do you see a point maybe at like 1, 2? Would that help you? A point at 1, 2 is going to do what? No. A point at 1, 2 is going to become 2, 1. So what do I have to do? I have to curve over and grab that point there. Notice the piece of graph that was going up is now going out. It was running more along that y-axis. Now it runs more along the x-axis. Have I made some helpful points?
Yeah.
Okay, that's my goal here. Look at some specific ordered pairs, take them and flip them. Okay. Anything that's on that is, you know, a pair such as 1, 1, 2, 2, 3, 3, 4, 4 is going to stay 1, 1, 2, 2, 3, 3, 4, 4. And then now, if I took my paper and folded it in half, would they land on top of itself? Hopefully close. We'll take close here, okay? This was not the easiest graph to reflect. Questions I can answer? You have a couple of homework you have to draw, if I recall. Give me your best shot. We'll talk tomorrow. Okay? Okay. Example 6. One last one. Now, notice the directions ask us to show algebraically, so you get to forget the graph, that f and g are inverse functions. If f and g are inverse functions, what has to be true? Fog equals x and Goff equals x. So what do we have to practice here? Fog and Goff, right? So I'm going to start with finding fog. Now, not proper math there when I say fog, but I don't know, it's what I like. Okay, so that's a composition circle, right? It's F composed with G. F composed with G, remember that we're going to do what? F of G of X. That's what it means we're going to do. We did this in what, 1.4? Okay, what are we thinking here? G goes into F. Can you visualize that and just go straight there? G goes into F. So what's the cube root thing goes into F. Where does it go into F at? X. So F says we're going to put something into X. We're going to cube it and add 1. What are we putting in that we're going to cube? Well, math is easy on this one. What happens when you cube a cube root? You get whatever's under that cube root. So we have x minus 1. What did we have at the end? Plus 1. What's x minus 1 plus 1? X. What did we just show? The fog equals x. Does that prove that f and g are inverses?
No.
No. Does a half prove it?
Yeah, kind of.
I'll take a half proof. Okay? In order to fully prove it, it has to work both ways. Okay, so you can't just stop and say, oh, it works, it's x, I'm good. No, now we need to go the other way. So now we've got to find Goff. Or, more appropriately said, G composed with F at x. So we're going to do G of F of x. This time I'm taking F and putting it into G. So G is supposed to be the cube root of x minus 1. So a cube root of something minus 1. So F is x cubed plus 1, and that's going to go in there. So the cube root of x cubed plus 1 minus 1. Well, what do we know under that cube root?
The cube root and the cube cancel.
Hold on, not yet, they don't.
Oh, they don't?
What do I have to do first?
We have to cancel off the ones.
Get rid of those 1s. You can't take the cube root of x cubed when there's other junk in there with it. Maybe I shouldn't use the word junk, but I mean, when there's other stuff in there, you can't do the cube root of x cubed. You can't do the cube root or square root or whatever when there is things being added and subtracted. So, 1 minus 1 though is 0. That's gone. What's the cube root of x cubed?
X.
X. Now what?
Proves that it's an inverse.
Okay, now we know that f and g are inverses, which we already knew. It just said show that they are inverses. There's your show. Okay? On the answer key tomorrow, it's just going to say fog equals x and Goff equals x on these because you have a couple in homework like this. It's about checking the word. Okay? Ooh, I'm glad I just looked at my notes here. Okay, page 1 through 122, 1 through 6, 9 through 12, 14 through 22 evens, and I have written in my notes no domains, and 23 through 29. So I don't remember, I didn't catch those directions yesterday when I was looking at it. 14 through 22, it must say something about domains in the directions, and I'm nixing that direction. Okay? I'll have to look and see what it is to remember. I think it might be finding the inverse. I don't remember. Okay, guys, you have a little bit of time. Use it, right?
Yes.